This is my geometry course. Today we're going to continue to learn circles, specifically sectors, chords, and graphs of circles. If you haven't done the homework completely and correctly from last class, do that homework before watching this video. We're going to start by learning what a sector of a circle is. A sector is just a region bound by two radii and the corresponding arc. So it's a region. And we're going to learn how to find the area of that region. Remember, area is two-dimensional. Length is just one-dimensional. You're just measuring the length of a line or a segment. But area is when you try to put squares inside and figure out how many squares fit inside. So you're measuring an actual two-dimensional region. And I want you to go ahead and get screenshots of all this. And in order to figure out how to find the area of a sector, we first have to recall how to find the area of the entire circle. Okay, this is the formula for the area of an entire circle. So you plug in r, the radius, and then you square it, raise it to the second power, and you multiply it by pi, and that gives you the area of the whole circle, all the inner part of the circle. It just gives you an idea of how big the circle is. Now, to find the area of a sector, we don't want the area of the whole circle. We don't want that. We just want the area of this part here, you see. To do that, you have to take the area of the whole circle and then you multiply it by a fraction. And that fraction is going to be determined by the central angle. So we have to have that central angle, whatever that may be. So you take that central angle and divide it by 360, because that's the full rotation, and then you multiply it by the total area, and that gives you the area of this small fraction of the circle, which is a sector. So again, get screenshots of this, and you're going to need these for the next 8 problems. So let's go ahead and get started. If M is the center of the following circles, find the area of the sectors below. You must use the pi button on your calculator and, of course, round to the nearest tenth. In the previous class, I think we rounded to the nearest hundredth, but I'm going to have you practice rounding to the nearest tenth in these problems. So what we're going to do is just write the formula. So I'm just copying down that formula. And then we just plug in the numbers that we need. So the central angle you can see is 52 in that picture up there. 52 degrees, and the radius is 2. Now there's a lot of different ways that you can punch in the numbers. At this point, it's really just a calculator problem. You're just going to use your calculator. And there's a lot of different ways you can punch in the numbers, but if you know, there is some room for error when punching in these numbers, so you have to be careful. I'm just going to show you, if for some reason you don't get the right answer, just do it the way that I do it. So 52 in your calculator, then divided by 360 equals. Then times the pi button, you must use the pi button, equals. Then you're going to push times again, 4 times 4, because 2 squared is 4, and then equals. And then you should get your answer. And by the way, I'm going to write an extra step there just so you can see that we changed that 2 squared to 4. I probably don't need to do that, but just for your sake. So when I do all that, I come up with 1.8. And we have to use approximately sign, approximately equal to. And we have to get the right units, and this is going to be square feet, because again, we're measuring area. It's very important that you write square feet, not just normal feet. Let's try number 2. As you can see, this is really pretty easy. It's no big deal. I'm going to continue to write the original formula, even though you're probably going to get bored seeing me write this over and over again. Because we have to show the tool that we're using. We have to write the central angle over 360 times pi times the radius, which is 46. Squared, and then it just becomes another calculator problem. I'm going to go ahead and square that 46. 46 squared is 2,116. And so again, you just enter the numbers into your calculator. Area is equal to, in your calculator you can do 117 divided by 360 equals times pi equals, then times 2,116 equals. So we get 2,160.5 square inches. And there you go. So again, in case you're wondering, again, we're just finding the area of these sectors. So we found the area of that sector, and we found the area of this sector. That's the yellow part. All right, let's do a couple more of these problems before you try some on your own. Actually, get a screenshot of these problems that we just did, and I think that was enough to do together. I think you're ready for a problem on your own. So go ahead and try number 3. I'm going to write this formula for you. I'm going to get you started. And just plug in the numbers and use your calculator. Now again, if you're going to make a mistake, it's probably going to either be your calculator or you're going to not use the order of operations properly, or so on and so forth. So just watch for that. Try number 3, and when you come back, we'll do it together. All right, we're back. So the area equals the central angle over 360 times pi r squared, and r is 3. So I'm going to go ahead and square that 3 because it's kind of hard to enter that. The reason I'm squaring it now is because it's kind of hard to enter into your calculator. That's the justification for that. So now it's just a calculator problem. So 140 divided by 360 equals times pi equals times 9 equals. And this is kind of an interesting rounding problem. If you had trouble rounding this, I'm sorry about that, but this is kind of a different rounding problem. You see, it says 10.995. So you look at the 10th place is the first 9 there, and you look to the right, and it's another 9. So that means you raise the 9 in the 10th place, and that raises up the 1. We don't have time to go into detail about rounding, but if you need review on that, just go to my arithmetic course. But we end up with 11, what is the unit? Square meters. So if you got 11 square meters, good job. Go ahead and try number 4, and when you come back, we'll do it together. All right, we're back. By the way, if you got the previous problem right, good job. So we're just writing the formula. We're showing the tool that we're using. And we have central angle is 75. And radius is 20. And 20 squared, that's just 400. You can use your calculator for that if you need to. And now we get out the calculator. So 75 divided by 360. And then times pi equals. And then times 400 equals. Now, again, if I didn't mention, there are different ways to plug that into your calculator. There's not just one way to do it. So if you want to try a different way, you can, but I would recommend just sticking to my method. If you round it off to the nearest tenth, you get 0.8. And this is inches, so square inches. If you got those answers, good job. If you didn't, that's okay. Just figure out what you did wrong. All right, so now we're going to go on to some problems that are pretty much the same thing, except now we're plugging in different numbers. So we're going to go ahead and write the formula. And in this problem, we're looking for the measure of angle LMQ. So that is a central angle. That's this angle right here, you see. And so we have various terms. So A equals theta over 360 times pi r squared. That's the formula we're going to be using now. We know the area of the sector. This is the area of the sector. So now we're plugging in area. So 126 is equal to theta, which we don't know, over 360 times pi times r squared, and r is 12. So now I'm going to go ahead and square 12. So we have pi times 144. 12 squared is 144. All right, now at this point, there's a lot of different ways to do this, but you know, I predict that a lot of students are going to have some trouble with this. So I'm going to show every single step here and be really careful to be exactly clear what I'm doing. If we want to, I can go ahead and just to simplify, I can write, usually the 144 is written before the pi. You don't really have to do that, but I just want to get rid of some of those parentheses. So at this point, we have an equation with fractions. And the first thing we want to do is get rid of the fractions. So that's theta divided by 360. So we're going to multiply both sides by 360. Let me move this over a little bit. Again, we want to get rid of that 360. So we multiply both sides by 360, and that gets rid of the 360 in the denominator. These cancel out, and you're left with theta times 144 pi is equal to 360 times 126. And you can put both these in parentheses if you want. Maybe that would be better. You only need one of them in parentheses. Now, I'm not going to multiply these together. I'm just going to keep them like that so we can see exactly what's going on. So at this point, I'm going to rewrite, and the reason I keep rewriting on some of these steps is I want you to see exactly what we're doing. I don't want you to get lost here at all. This is just basic arithmetic. These are just basic algebraic equations, but I want you to see what's going on. So now we have 144 pi times theta. We're trying to get theta by itself. I probably should have mentioned that earlier, but you should know that by now. I mean, if you have an equation with a variable, you're just trying to get the variable by itself. You're trying to isolate the variable. So because this is multiplication, we're going to divide both sides by 144 pi to get rid of that 144 pi. So now we have theta is equal to 360 times 126 divided by 144 pi. And all we have to do is calculate that, crunch the numbers in our calculator, and we're done. So 360 times 126 equals, divided by 144 equals, divided by the pi button equals. So we get 100.3. And notice that I just flipped the equation there. I just prefer to have the variable on the left side. It doesn't really matter. And our units are, we found the angle. We found the central angle, you see, this central angle here. So if we found an angle, obviously the units must be degrees. So we write 100.3 degrees. And we rectangle, and that angle should make sense when we look at this picture. So let's compare it to the picture if my computer will catch up. Yeah, so this is 90, you see this is 90 degrees right here. So our angle should be a little bigger than 90, which is 100.3, so that makes sense. All right, let's try another one of these problems. Number 6. We're given the area, and we're given the corresponding arc of that central angle, and we're asked to find the radius. So let's go ahead and write our basic equation. For these problems, it's good to just write that area of a sector equation, and then you can just kind of plug in and figure out what we need to do as we go along. You don't always have to know exactly what you're going to do before you start writing things down, because sometimes writing things down on paper will help you. So we know the area is 4.3, and we actually do know theta. See, we know the measure of this arc, but remember the measure of an arc is equal to the corresponding central angle. So that's equal to this angle here, you see. So we do know theta is 31 degrees. What we don't know is r. We're looking for the radius, you see. But we're going to use that information to find the radius. So at this point we have an equation with a fraction, and we're trying to isolate r. This is actually an equation with a fraction and a square. We need to isolate r squared. So I'm going to multiply both sides by 360 to get rid of that fraction, because that's the opposite of dividing by 360. And then we get 31 times pi r squared equals whatever 360 times 4.3 is. And I'm going to put a little divider here. And now I'm going to regroup. I'm going to put the 31 and the pi next to each other. That's the associative rule of multiplication. You can multiply in any order you want, pretty much. And at this point, we want to get r by itself. So we have to divide both sides by 31 pi. And then we're left with r squared is equal to 360 times 4.3 divided by 31 pi. And we now have r squared. We don't want r squared. We want r. We want the radius. So we have to get rid of that square. To get rid of a square, you do the opposite, which is square rooting. So we have the square root of 360 times 4.3 over 31 times pi. And it would be plus or minus, but we don't really need the plus or minus, because obviously a radius cannot be a negative number. So at this point, this may be a little difficult to plug into your calculator, so pay attention very closely. 360 in your calculator times 4.3 equals, divided by 31 equals, divided by the pi button equals. Now, once you get that number, then you're going to push this button. Let me write it down here. I'll just write it here. It's going to look like this, or it might look like this with a 2 there. Do not push this button with a 3. That is not what we want. That's cube root. We want a square root. So push that button. So I'm going to push that button right now. I'm using an iPhone. And you know, if you're using a what's it called, the Google phones, it might just be this symbol, and you might have to enter the number. You might have to put this symbol in first, and it'll probably have like a parenthesis somewhere, like a parenthesis there, and then you'll put the number in. But after doing that, we get, whoops, why isn't there a equal sign there? I'm sorry about that. We get, rounding to the nearest 10th place, we get 4. And that is 4 meters. So I want you to, if you need to, you can take screenshots of those problems we just did, because you may use those as we go along here. Actually, let's do one more of these problems before you try one on your own. This one's going to be a little easier, so that's some good news. So we're just using the area of a sector formula to figure out numbers. So area we have is 39, theta we have is, we know that this arc measure is 178, so that means the corresponding central angle must be 178 also. That's just the definition of arc measure. It's equal to the corresponding central angle. So that would be 178 divided by 360 times pi times the radius squared. And so what are we looking for? We're looking for the area of circle M. Now, remember, these formulas tell us the area of any circle is pi r squared. That's the area of a circle. So that's what we're looking for. If we can find pi r squared, if we know what that equals, then we have the area of the circle. So all we have to do, because we have pi r squared right here, all we have to do is just isolate that, and that will be the area of the circle. So all we have to do is get rid of this and isolate this, and we're done. So that's why this problem is a little easier. So the first thing we're going to do is go ahead and rewrite that, because I want to show every single step. And also, I don't think I mentioned, you don't have to show every single step here. It may seem a little complicated because we're showing every single step. You don't have to do that if you know this, if you know how to do each step, if you know exactly what's going on. I'm just assuming that some students are going to have some trouble with this, so I'm going to show every single step. But it doesn't have to take this long for you if you know the algebra. So the first step is to get rid of the 360, the fraction. And remember, whenever you have an equation with fractions, you always multiply by the lowest common denominator. And the lowest common denominator is obviously 360 because there is no other denominator except over here. Maybe you could consider that to be 1. The lowest common multiple of 360 and 1 is 360. All right, so now we're going to regroup because we're trying to, we're not going to regroup. I forgot, we're looking for pi r squared. So now we're going to take that and we're just going to divide out the 178 and isolate pi r squared, and then we're going to be done. So pi r squared is exactly equal to whatever 360 times 39 divided by 178 is. And that's the area of the circle. That's what we're looking for. So in your calculator, we do 360 times 39 equals, divided by 178 equals. And we get 78.9. 78.9. And this is area, so we need area. Area is in feet squared. So let's see if that makes sense. The area of about half the circle is 39. You see, 39 square feet. So about double of that should be the area of the whole circle, which seems right, 78.9. All right, so again, you can get screenshots of the first 3 problems we did there and the screenshot of the problem we just did. And now it's time for you to try, so go ahead and attempt number 8. You're looking for the measure of angle AMC, so that's this angle here. So that's going to be theta. You're looking for theta. So go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. So I'm going to start by writing that formula. And we'll plug in what we know and solve for what we don't know. So we know that the area of the sector is 26, and we're looking for theta, so we don't know what that is. And we know that the radius is 8, so 8 squared. 26 is equal to theta over 360. Pi times 64. 8 squared is 64. And now we're just going to rewrite and multiply both sides by 360. I'm going to go ahead and I'm just going to write 64 pi because it's typical, it's traditional to write the number before pi. And so we're going to multiply by 360. And that's going to cancel out that fraction. And let me write a divider here. So we have theta times 64 pi is equal to 360 times 26 over, actually, whoops, sorry. We're left with that, and I'm going to go ahead and rewrite. Again, I'm trying to show every step here just so you know exactly what's happening here. You don't have to show every single one of these steps. You do have to show some work, but not every single step. I'm just doing this so you see what's happening. So then we're left with theta is equal to 360 times 26 over 64 pi. And that's what we're looking for, the measure of the central angle, AMC. So in your calculator, 360 times 26 equals, divided by 64 equals, and then divided by the pi button equals. So it's 46.6. Theta is approximately equal to 46.6 degrees, because this is an angle. So it's always important to go back and see if this actually makes sense. So does that look like a 46.6 degree angle? This angle here, does that look like 46.6 degrees? Well, this is 90 degrees, so 46.6 should be about half that, and it does look like about half that angle. So if you got that right, good job. All right, go ahead and try. I'm going to leave those in the window. Go ahead and try number 9. Now for number 9, we're looking for diameter. Now, remember, radius is half of diameter. So you're going to find radius with that formula, this formula here. And once you find radius, then you're just going to multiply it by 2, and that'll give you the diameter, because the diameter is double the length of the radius. So go ahead and try number 9, and when you come back, we'll do it together. Remember, if this arc is 145, then that means that this central angle is also 145. That's important. So try number 9, and when you come back, we'll do it together. All right, we're back. So let's start by writing the formula, as usual. The area we know is 62. Theta we know is 145. And R we don't know. That's we're going to need to find R. So the first thing we want to do is get rid of that fraction. We have an equation with a fraction. You get rid of it by multiplying by the lowest common denominator of all the fractions involved. And we only have one fraction involved, so the lowest common denominator is just 360. And so we end up with 145 times pi r squared is equal to 360 times 62. And now we're going to divide both sides by 140. Actually, we're just going to regroup. So I'm going to put the pi next to the 145. And we're trying to isolate r squared. And so we divide both sides by 145 pi. Let me write that a little better there. 360. And so we get r squared is equal to 360 times 62 all over 145 pi. So we found r squared. We don't want r squared. We want r. So you square root both sides, and that gets rid of the square, and then you have plus or minus 360 times 62, and blah, blah, blah. You get the point. Just fill it all in. So now r is just going to be, some approximate number, and we don't really have to write that number, but I'm going to write it just for educational purposes so you can see what's going on. So again, if you're going to have trouble with this, it's probably going to be that you're not entering it properly in your calculator. So 360 times 62 equals, divided by 145 equals, divided by the pi button equals. Then you're going to push the square root button, and that's going to be r. And again, the square root button it's going to look something like this, or with an Android phone, it might be something like that with a parenthesis. Or if you have some other calculator, it might be something different, but you need to figure it out. So rounding off to the nearest 10th place, that's kind of a different rounding problem. But again, we're not teaching how to round in this course. That should be something that you know by now. If you can always review in my arithmetic course. So 7 inches. Oh, wait a second. I'm sorry. Before we round, I'm going to carry out those numbers because we don't want to round off until we get the final answer. So we got something like that. And then I'm going to push times 2 in the calculator equals, and then we'll round off and we get 14. I guess it didn't make any difference in this particular problem. But the diameter is that times 2, and I just want to show that. So it's 2 times 6.9998. So the radius is, the diameter, if my computer will catch up, the diameter is equal to approximately 14 inches. So if you got that answer, good job. Again, if you got stuck somewhere, don't worry, just figure out what you did wrong. All right, so go ahead and try number 10. This is the last problem for you to try, and then we'll go on to something else. So in this problem, we're looking for pi r squared. It's going to be an easier problem. You just have to isolate pi r squared in that expression because that is the area. We're looking for the area of the circle M. So try number 10, and when you come back, we'll do it together. All right, we're back. Area equals theta. Area of the sector equals theta over 360 times pi times r squared. We know that the area is 13. And the central angle we know is 70 degrees because that's the same number, same angle magnitude of the arc. So 70 over 360 times pi times r squared. Now we're looking for area of the circle, so we just need to isolate that. So we're going to multiply both sides by 360. So I'm going to rewrite just so we can see what's going on. Again, you don't have to rewrite this, but I'm just doing it to make sure you guys know exactly what's going on here. So we're going to multiply by 360. And then we get 360 times 13 equals 70 times pi r squared. Then I'm going to go ahead and, first I'm going to rewrite. And then I'm going to divide both sides by 70. We're trying to isolate pi r squared. And we get pi r squared is equal to 360 times 13 divided by 70. And in your calculator, 360 times 13 equals, divided by 70 equals. And we get, if you round off to the nearest tenth, we get 66.9. So pi r squared is equal to 66.9. And that should be in square centimeters. So if you got that answer, good job. It should be, it should make sense. So this sector here is only about I don't know, maybe 1/5 of the circle. So 5 times 13 should roughly be our answer. So 5 times 13 is 65, and you can see it's roughly our answer. So it's always good to check your answers on these problems, especially when you're taking a test or, you know, in some context where you need to get the right answer. All right, so that's the area of a sector. We're done with the area of a sector. Now, I didn't mention, you may recall that this formula is very similar to the formula for area of arc length. The only difference is that this is the circumference. You're taking the circumference and finding a fraction of it, which is arc length. With this, you're taking the area and finding a fraction of it. So that's one way to memorize that formula, is to understand that it's almost the exact same formula as the arc length formula, and also the concept of finding the total area and then multiplying it by a fraction to make it smaller. That's really not that difficult to understand. Technically, anything relating to fractions actually is pretty difficult to understand, but the justification for the derivation of the formula is not that difficult conceptually. All right, so now we're going to chords. You can go ahead and take a screenshot of this if you want with your phone or with your computer. We're going to use this as we go along. First, we need to learn about congruent arcs. So I probably should have went over this earlier, but it doesn't really matter, I guess. But if you have an arc here, say, that's congruent to an arc over here, what that means is that the arc measures are equal. That's all that means, and that's pretty obvious. You can probably figure that out without me telling you, but we do need to define congruent arcs to go on to these next problems. Also, congruent circles. Congruent circles are just circles with the same radii. So if the radius of one circle is, say, 3 centimeters, if another circle is congruent, that means the radius of it is also 3 centimeters. If you draw the circles, those circles are not the same size, but they should be the same size. Now we're going to learn the Arc-Chord Pair Congruence Theorem. And this theorem is actually kind of obvious. It says the minor arcs created by two chords in the same circle are congruent if and only if the chords are congruent. So these arcs, the minor arcs, you could write the major arc of that chord, which would be this, but we don't care about the major arc. The minor arc of this chord, created by this chord, is congruent to the minor arc created by this chord if the chords are congruent. And notice it says if and only if. Now, it's been a while since we learned this, but remember, if something says if and only if, that means the converse is true also. So what this theorem tells us is that if these two chords are congruent, then that means the corresponding arcs are congruent. On the other hand, the converse of that is true. If the arcs are congruent, created by the chords, then the chords are congruent. So again, this is pretty simple stuff. So if you didn't understand that, that's okay. We're going to do some practice problems, and you're going to see exactly what this means. So it says find the following values: measure of angle or measure of arc AB. Now you see these little green tick marks in these chords. That means that those chord lengths are equal. So that means that the corresponding arc measures will be equal also. So one of them is 89 degrees. So that means that the measure of arc AB must be 89 degrees also, and we're done. Pretty simple. So these are pretty easy. Over here, we have two arcs that are the same measure. They're both 95. Do you see that? So that means that the length of the chords must be congruent, or that it must be equal. So FE is equal to 26 meters because GH is 26 meters. Very simple. Let's see here. Let me get an idea of how many of these we need to do. Looks like we have two more of these to do together. We're looking for the measure of angle IPK. So the measure of angle IPK, that would be this angle here. We're looking for that measure, that angle measure. Now, if we can find the corresponding arc measure, then we can use that to find the central angle measure, because the central angle measure is the same as the corresponding arc measure. This is all stuff that we learned in the previous class. So now we know that these two chords are congruent, right? They're both 8 meters. So that means the corresponding arcs are both congruent. So if this is 155, that means that this must be 155. So we can say that K, let me see here, the measure of arc Ki is equal to 155 degrees, and that is equal to the measure of angle IPK. So the final answer, measure of angle IPK, is equal to 155 degrees. So this is all based on stuff that we did in previous classes and this theorem that we just learned. All right, we're going to try one more of these together before you try one on your own. Notice that these arcs have equal measure. That's what those green tick marks mean. So that means that the chords must have equal measure. So 5x minus 6 must be equal to x plus 6. Subtract x from both sides, and you get, let me save some space here. Subtract x from both sides, and you get 4x. Add 6 to both sides, and you get 12. Divide both sides by 4, and x is equal to 3. We don't want x. We want AC. AC is equal to the number we just found, x plus 6. So AC is equal to 9, and that is the answer. So pretty easy stuff. All right, so I'm going to leave all those in the window along with the theorem that we learned. And I want you to try number 15. And when you come back, we'll do it together. All right, we're back. These are congruent chords because they're both 13.7 inches, which means that the corresponding arcs must be congruent. So the measure of arc AB must be equal to 110 degrees. So if you got that answer, good job. That should be an arc, not a V symbol. All right, so now we're looking for HG. Go ahead and try number 16, and when you come back, we'll do it together. All right, we're back. Notice these tick marks here on the arcs. That means those arcs have the same measure, which means that the chords must be the same length. So the length of HG must be equal to 86 feet. And you might be thinking, aren't these kind of easy? Well, yes, they are easy, but you still have to learn this theorem. All right, on to the next problems. We have 2 more of these for you to do, so try 17, and when you come back, we'll do it together. All right, we're back. The arcs are congruent, which means that the chords must be congruent also. So LN is equal to 5 inches. So if you got that answer, good job. All right, so go ahead and try number 18, and when you come back, we'll do it together. All right, we're back. You see these chords, they have the same length because they have that purple tick mark. And so that means that the corresponding arcs must have the same measure. So that means 10x plus 65 is equal to 25x minus 10. And subtract 10x from both sides and add 10 to both sides. And then divide both sides by 15. And we get 5. But we don't want x. We want the measure of DC, arc DC. So the measure of arc DC is equal to 25 times the x value we just found minus 10. 25 times 5 is 125 minus 10 is 115 degrees. So 115 degrees is our answer for that one. And I'm just going to move this up a little bit. So the measure of arc DC is equal to 115 degrees. All right, so if you got that answer, good job. On to another theorem here. This is called the Chord Perpendicular Bisector Theorem. If a chord in a circle is a perpendicular bisector of another chord, then the first chord must be a diameter of the circle. So you can take a screenshot of that if you want. And if you don't understand exactly what that means, that's okay. We're going to do some practice problems. Now, we know that this chord bisects AD. And we know that because one side here is 4 inches and the other side is also 4 inches. So we know that BC bisects AD. Now we also know that this angle here is a right angle because it says the measure of angle DEC, actually not that angle. This angle here is a right angle because the measure of angle DEC is 90 degrees. So that means that BC is not only a bisector of this chord, but it's also a perpendicular bisector. So that theorem that we just went over said that if this chord, if any chord is a perpendicular bisector of another chord, then that means that that chord BC is a diameter. So we can say BC is a diameter because it's a perpendicular bisector of chord AD. And you could give a more formal proof of that, but we don't really need to. Sometimes in geometry you're required to do a formal proof, sometimes you're not. I'm not going to require you to do a formal proof on this, and I'm going to go ahead and rectangle that because that's our whole answer there. So let's do one more of these. Chord BC, that bisects DA. Do you see why? Because those green tick marks. That means this length is equal to this length, and so BC bisects AD. But when you look at the angle between those, 89 degrees, you see that it's not a right angle. It's not 90 degrees. So that means even though BC bisects DA, it's not a perpendicular bisector. So you can say we cannot use the, and what is it called? The Chord Perpendicular Bisector Theorem. The Chord Perpendicular Bisector Theorem. Because, and we can write just B/C, because we can just say because BC is not perpendicular to DA. All right, so that is the answer to that one. So I'm going to leave those in the window, and I want you to try number 21, and when you come back, we'll do it together. All right, we're back. BC is perpendicular to AD, so that's good, but it's not a bisector of AD because this side is 35 and this side is 36. So we cannot use the chord perpendicular bisector theorem because BC, I don't know why I put an extra article in there, sorry about that. In that problem up there I wrote the BC, which doesn't make much sense. Because BC does not bisect, AD. So this is just giving a brief explanation of why we cannot conclude that BC is a diameter. All right, so if you got that answer, good job. It should be something along those lines that you wrote. So now try number 22, and when you come back, we'll do it together. All right, we're back. It says here BC is perpendicular to AD, so we know it's perpendicular. And also we see these red tick marks, so that means that it is a bisector. So at that point we can then conclude that BC is a diameter because it's a perpendicular bisector of AD. And that's it. So if you got that answer, something along those lines, good job. All right, on to number 23 here. We're going to learn a new theorem. This theorem is kind of the opposite, not exactly the converse, but pretty much the opposite of the previous theorem that we learned. This theorem says if a diameter or a radius of a circle is perpendicular to a chord, so if we know this is a diameter, in the previous problems we didn't know it was a diameter. We were trying to conclude that. But now we know it's a diameter. It can be either a diameter or a radius. If a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord and the corresponding arc. So go ahead and take a screenshot of that theorem. And we're going to go ahead and do some practice problems here. If B is the center of each circle below, find the following values. All right, so we know this is a diameter because it goes through the center B. We also know that it's perpendicular to this chord. So by that theorem, because those two things are met, we know that it bisects this chord. DC bisects the chord AB, and it also bisects the corresponding arc. So that means it hits right in the middle of that arc, which means that this side must be 56, just like this side is 56 degrees. And this length here, of course, is 2 inches. So we want the measure of arc CB. So the measure of arc CB is equal to 56 degrees. That's pretty easy. And now we want AB. Now AB is equal to 2 times 2 is equal to 4. So AB is equal to 4 inches. Just be aware it's not looking for AE in this problem. It's looking for AB. So you have to add that. You have to add 2 inches plus 2 inches is 4 inches. On the next problem, so DH. First of all, this is a radius because it's going through the center B. We were told that B is the center, and it's also perpendicular to this chord. So that means it bisects the FB bisects DE. And also it bisects the corresponding arc. So that means that DH is equal to 20 centimeters. If this is 20 centimeters, then this must be 20 centimeters also. And measure of arc DE is equal to 2 times 71 degrees. Which equals 142 degrees. So the measure of arc DE is equal to, and I'm going to explain why that is as we go along here. Let me just write it down first. So FB bisects the arc DE. So that means if this is 71 degrees, then this must be 71 degrees also. Now we're looking for DE, so that's just 71 times 2. And that's why we multiplied it by 2, so we get 142 degrees. All right, on to 25. Let me get an idea of how many of these we have to go. We're looking for NL and measure of arc NL. So we know that QP, it's a perpendicular to NL because we have that 90-degree angle there. that right angle. But the problem is QP does not go through the center. So we know that QP is not a diameter. In order for this theorem to work, QP has to be a diameter. So we can just say that we cannot use the perpendicular diameter theorem because QP is not a diameter. All right, so we have two more of these before you try one on your own. Now in this problem we know that dB is a radius because it goes from the center to a point on the circle. And we also know that it's perpendicular. So that means that it bisects this this chord. So that means that 3x plus 1 must be equal to 4x minus 3. Subtract 3x from both sides, add 3 to both sides, you get 4. Then we're looking for EC. So EC is equal to 4 times the x value we just found minus 3. So EC is equal to 16 minus 3, which is 13. And there you go. All right, one more of these problems before you try one on your own. We're looking for the measure of arc LNM. So that is this arc here. So what we're going to do is we're going to find, we know that this diameter is, we know it's a diameter because it goes through the center, and we know that it's perpendicular. So therefore we can use the theorem. That means that this arc is bisected by that diameter, and therefore that means that this value must be equal to this value. So first we're going to find x, plug it back in, find these values. Then we're going to use those values. We're going to subtract, add those together and subtract from 360 to get measure of arc L and M. I'm sorry if that seems kind of confusing, but it's just it's a multi-step problem. So that arc is LM is bisected. So then we're going to add 5x to both sides and subtract 25 from both sides. Then we're going to divide both sides by 2. And we get negative 10. So x is equal to negative 10. Now I'm gonna find there's a bunch of different ways you could do this, I guess, but I'm gonna find the measure of arc LQ first. So the measure of arc LQ is equal to 5 minus 5 times the x value we just found, which is equal to 55 degrees. Now that means that LM, this entire arc here, is just the sum of those two. The sum of it's just 55 times 2. So arc LM, measure of arc LM, is equal to 2 times 55, which is equal to 110 degrees. And the measure of arc LNM, which is ultimately what we're looking for, is equal to 360 minus 110, which is equal to 250 degrees. So I know that seemed like a lot of work, but you know, some of these problems, they're just multi-step problems. Just you figure it out and buckle down. It's kind of like a puzzle. You just have to solve the puzzle. All right, so now it's time for you to try. Go and attempt number 28, and when you come back, we'll do it together. All right, we're back. Now we know that this is a radius because it it goes through the center, and we also know that it's perpendicular. We see the right angle there. So that means that it bisects that chord and the corresponding arc. So if CA is 3 meters, then that means that AE must also be 3 meters. And if this arc is 84 degrees, then this arc must also be 84 degrees. And the measure of arc CE, which is the sum of those two arcs, must be 2 times 84, and that would be 168 degrees. So if you got those answers, good job. If you didn't, that's okay. Just figure out what you did wrong. Now you can take a screenshot of this stuff if you want, because we're going on to the next page. It's just more of the same problems, but you can refer back to those on your phone if you need to. So try number 29, and when you come back, we'll do it together. All right, we're back. Now this is a diameter because it goes through the center. But look, we don't know that these two chords are perpendicular. There's no right angle. So this was kind of a trick one. If you did the problem, then you got tricked. That's okay. Don't feel bad. But we cannot use the theorem. We cannot use the chord perpendicular bisector, or excuse me, the perpendicular diameter theorem. The perpendicular diameter theorem, because BD is not perpendicular to AC. And you know, to be more accurate, we can just say it might not be perpendicular to AC, because just because we don't have the angle doesn't mean that it's not 90 degrees. You know, we just don't have enough information. All right, so I'm sorry if you got tricked on that one. But that's a good lesson. Sometimes in these problems, the answer is we just can't use we don't have enough information. So go ahead and try number 30, and when you come back, we'll do it together. All right, we're back. This is a radius, and it's perpendicular. So now we have that extra piece of information perpendicular to the chord CD. So now we can use the theorem that says that AD, if CA is 27 feet, then AD must be 27 also, because that chord is bisected. So AD is 27 feet. Now the measure of arc CD, that is just 2 times 55, which is 110 degrees. Because again, the arc is bisected also, which means that if this is 55, this must be 55 too. So to find that whole arc, CD, the measure of the whole arc, then you just add those two together. So the measure of arc CD is equal to 110 degrees. So if you got that answer, good job. Okay, try number 31, and when you come back, we'll do it together. All right, we're back. Now, BD is a radius because it comes from the center, and it's also perpendicular, so that means we can use our theorem. So the arc QF is bisected by BD, so that means 4y plus 1 is equal to 45. Subtract 1 from both sides, and we get 44 is equal to 4y. Divide both sides by 4, and we get y is equal to 11, and that's what we're looking for. So if you got that answer, good job. Try number 32, and when you come back, we'll do it together. All right, we're back. So this is a diameter because it's going through center B, and it's also perpendicular to BD because we have that right angle there. So we can use the theorem, and that says that the the chord BD is bisected. So that means that 3a plus 6 is equal to 7a minus 2. Subtract 3a from both sides and adds 2 to both sides and divide both sides by 4, and we get a is equal to 2. We don't want a. We want BD. And I'm going to just move this up a little bit. So BD is equal to, let's see here, 2 times BE, which is equal to 2 times 3. You know, this is getting kind of complicated here. I'm going to do a little step by step. So first I'm going to find BE. BE is equal to 3 times the A, which we just found, and that is 12. And then BD, which we're actually looking for, is just 2 times 12, which equals 24. And there you go. So if you got that answer, good job. All right, so on to the next problems. These problems are the same type of thing, but they're a little tricky. They're not difficult, but they're a little tricky. So we want to find the length of AD. Now, normally we're given the length of DC because this radius, that segment is a radius coming from the center, and it's also perpendicular to the chord. So that means it bisects this chord. So if we know this length, we can find this length. Problem is, we don't know this length. So what's going on here? How do we solve this? Well, we're going to do a little trick. What we're going to do is we're going to extend a radius from the center all the way to a point on the circle. Now, here's the key. This is a radius, just like we just said, right? But this is a radius also. This length is 3 and this length is 2. So if you add those up, you get this radius is 5 units. But that means that this radius must be 5 units also. All radii of this circle are all the same. They're all 5 units. So you might be thinking, who cares? I don't get it. How does this help us? Well, if we know that this side is 5, that's the side here, and we know that this side here is 3, and we know this angle is a right angle, I just took this triangle here, which is a right triangle, and pulled it out here. So that means that we can use the Pythagorean theorem to find DC. This is DC. And then because this is a radius that is perpendicular to AC, the chord AC, we can then say that this length is the same as DC. Now again, that may seem a little complicated, but sometimes you have to do complicated problems in math, so you're just going to have to get used to that. Math is challenging. There's nothing you're going to do to make it to where it's just a walk in the park. Sometimes you're going to get multi-step problems. So let's do the math. You're used to seeing a squared plus b squared equals c squared, even though those numbers don't correspond. So for b, I'm just going to write dc, and the hypotenuse is 5, and for a, I'm going to write 3. Remember, the most important thing is to understand which numbers are legs of the right triangle, which number is the hypotenuse. So now I'm going to subtract 9 from both sides, and I get 16. Square root both sides, and we're out of room. We don't have any room, but that's okay because we can just use an arrow. That's going to happen a lot. You just have to be able to deal with it. So now we get plus or minus 4, but remember, a length in a real world cannot be negative, so it's just going to be 4. So that means that because DC is 4, that means AD must also be 4, and we're done. So again, these problems are not difficult, but they're a little tricky. Let's try number 34, and then you can do one on your own in the next problem. Now, we know that this is a radius, and we know it's perpendicular. So we know that this length is equal to this length based on the theorem that we were using before. But we don't know what QS is. We don't know that length. So what we're going to have to do is draw a radius, and that radius, if you pull it out, let me do a divider here. If you pull that triangle out, you have something like this, and that radius must be 5 plus 8. 5 plus 8. And this side is 5. If you see that, if you see what's going on there, this is really not that difficult. But if you don't see that, this is going to be challenging. Again, just to be clear, sorry, I'm just waiting for my computer to work. To be clear, this is a radius because it goes from the center all the way to a side of the triangle. So if you add those up, you get whatever, 5 plus 8, which is 13. But the distance from B to Q, that's also a radius, so that must be 5 plus 8. So we can take that triangle out and set it over here. And then we can just use the Pythagorean theorem. So now we have 13, 5, and we're looking for QS. So again, the letters you're used to are a squared plus b squared equals c squared. I'm just writing that because it's familiar to you, but those letters don't really make sense in this context. So I'm going to replace b with qs, and a we're going to replace with 5. Those are the legs, and the hypotenuse is 13. And we get 169 is equal to qs squared plus 25, subtract 25 from both sides, and you get 144 equals qs squared. And we're going to square root both sides, and we get qs is equal to, you know what, let me make some more room there. We're not allowed to go right to left. So what I'm going to do is I'm going to move all this stuff over here and move this on to the left, so then we can go left to right rather than right to left. And I'll just put this stuff up here, I guess. So now we can say square root both sides, and qs is equal to 12. But we don't want qs, we want ql. So ql is equal to 2 times 12, or ql is equal to 2 times 12, and we get 24. So again, these problems are a little tricky, but you can do them. So try number 35, and when you come back, we'll do it together. All right, we're back. So we're going to be using this triangle here, and I'm going to bring that triangle out and draw it. This side is 8 plus 9, and this side is 8, and we're looking for WV. And I probably should have, yeah, I wrote that. Just wanted to make sure I did that. So then rewrite this triangle with the new length, which is, that would be 17, 8, and WV. And the Pythagorean theorem we're used to is like so. Plug in WV, plug in the hypotenuse, which is 17, and the other leg, and we get 64 plus WV squared is equal to 289. You can use your calculator if you want. And subtract, and we get 225 is equal to WV squared. Now we're out of room, that's okay, we can just go up here, and square root both sides, and 15 times 15 is 225. So WV is now 225, but if WV is 225, that means WV is 15, so UV must be 2 times 15. So UV is equal to 30. And again, that's because BT bisects UV. So if WV is 15, that means that UV must be 2 times 15, because this side is just 15 also. So because of the segment addition postulate, we can just times that by 2. So if you got that answer, good job. Go ahead and try number 36, and when you come back, we'll do it together. All right, we're back. Same situation. And by the way, I didn't mention you can actually use this triangle, or you can use this triangle or this triangle. Both of them work. I didn't mention that before. I probably should have. So I'm just going to use this triangle here and pull that out, and we get, let's see, this side would be 8, and the hypotenuse would be 8 plus 2. And so we have 8, and then 10, and then the unknown side would be AE. And this time, that's the actual, that's what we're actually looking for, is AE. So that's AE. And so now we're going to use the Pythagorean theorem. Again, these letters don't correspond to anything. They're the wrong letters to use, really, but I'm just showing you that because you're used to that form of the Pythagorean theorem. And A is 8, so we have 64 plus AE squared is equal to 100. Subtract 64 from both sides, and we get AE squared is equal to 36. And then move everything over, because remember, in math you can never go from right to left. You have to go left to right. And we go up here. Looks like we missed a power there. And square root both sides, and AE is equal to 6. And that's it. So sorry, it was kind of scrunched in there. So if you got that answer, good job. All right, on to the last chord theorem. This is called the Equidistant Chords Theorem. Two chords in a circle are congruent if and only if they are equidistant from the center of the circle. So if this chord is congruent to this chord, then that means the distance from the center must be equal. So they're the same distance from the center. Now the reason we have these these right angles, and this is something that the geometry curriculum sometimes fails to mention, but it's assumed that the shortest distance from a point to a line or a segment is the perpendicular distance. So that's why we need those right angles. So if those chords are congruent, then the distances from the chords to the center are also equal distances. But look, it says if and only if. So that's a biconditional statement, which means the converse is true also. If the distance of two chords from the center is equal, then that means the chords are congruent. So the converse of that is true also. So this is going to be a pretty easy problems here. This is not a difficult theorem at all. So go ahead and take a screenshot of that if you want to look at that on your phone as we do some practice problems. If L is the center of each circle below, find the following values. Now look, these two, the distance of each chord from the center is both 8. The distances are both 8, so that means they're equidistant chords from the center. So that means by that theorem, the chords must be congruent. So the chord lengths must be equal. Subtract 4x from both sides, add 2 to both sides, divide both sides by 2, and x is equal to 4, and that's what they're looking for. So pretty easy with these problems. 38, notice that the chords are congruent. They're both 10. The length of the chords is both 10, so that means they must be equidistant from the center. And add y to both sides, subtract 7 from both sides, divide both sides by 4, and we get -1 for y, and there you go. Now if you plug in -1 to those expressions, you get a positive number. We can't have a negative length. If we got a negative length, then that would mean there'd be no solution to those particular problems. All right, let's do one more of these problems before you try one on your own. You see these arcs? These arcs are both 60 degrees. Now remember, we learned in the first of those chord theorems, we've done 4 chord theorems now. In the first chord theorem that we learned that if the arcs are congruent, the arcs created by 2 chords are congruent, then the chords themselves are congruent. So that means because we know that these arcs are both 60 degrees, that means that these chords must be congruent. But if those chords are congruent, then by the theorem that we learned previously, that means that they must be, the distances from the chords to the center must be equal. So that means that 4x plus 11 must be equal to 8x minus 1. Subtract 4x from both sides, and add 1 to both sides, divide both sides by 4, and we get x is equal to 3, but we don't want x. We want LJ. So LJ is equal to 8 times the x value we just found minus 1, which is 23. And let me move this up a little bit. So LJ must be equal to 23. So as you can see, these theorems are pretty easy. Now it's time for you to try number 40. Go ahead and try number 40. Number 40 has a decimal, so I'm sorry about that. You can use a calculator if you want. Try number 40, and when you come back, we'll do it together. All right, we're back. Notice that the chords are congruent. They have the same length. So that means that they're equidistant from the center, which means that 2b plus 3 must be equal to 8b plus 8.4. Subtract 2b from both sides, and we get 6b. Subtract 8.4 from both sides, and we get -5.4. Divide both sides by 6, and we get b is equal to -0.9. And that's it. So we got -0.9. Good job. Whoops. Well, actually, never mind. I thought that was going to have units, but it didn't. So let's try number 41. I'm going to leave all this stuff in the window. Go ahead and try 41, and when you come back, we'll do it together. All right, we're back. The chords are equidistant from the center, which means that the chords must have the same length. So subtract 4c from both sides, add 28 to both sides, and we get c is equal to 5, divide both sides by 5, and that's it. So if you got that answer, good job. Try number 42, and when you come back, we'll do it together. All right, we're back. Notice that the chords, or the measures of the arcs created by those chords are equal. So that means that the chords are equal. So again, if you're confused by this, we have to go back to the first chord theorem that we use, because this is actually using multiple chord theorems. We know that if those arcs are congruent, the chords that create those arcs must be congruent also. So this tells us that these chords have equal length. But if the chords have equal length, that means that they must be equidistant from the center, which means that if one side is 3 inches, the other side must be 3 inches also. So that was pretty simple. Not simple in the sense that we had to use 2 theorems there. but simple in the sense that we didn't have to do any algebra. So if you got that answer, good job. If you got stumped by that one, that's okay, as long as you understand it now. All right, so now we're going to go on to the last thing that we're going to learn today, graphing circles and writing the equations of circles. So this is the equation of a circle with center HK and radius R. So go ahead and get a screenshot of that or a picture with your phone. H is the x value of the center coordinate, and K is the y value of the center coordinate. So it says here, write the equations of the following circles. So I'm going to go ahead and write that equation that we just saw up there, just so you know what tool we're using. So we need to look at this circle over here and find the center. So notice that these points are on the circle. So what you can do is just kind of draw a cross, and you can see there that center point there. So that center point is negative 2, 2. 1, 2, 1, 2, negative 2, 2. So you plug in negative 2, that's the x value of the center, and then plug in positive 2, that's the y value of the center. And now R is the radius. So we just need to count from the center to a side, and that's 1, 2. So the radius is 2. So we just plug in 2 for R. Now it's important to understand this is a double negative. So x minus negative 2 is x plus 2. We want to simplify that. Never leave it as a double negative because it needs to be simplified. And we square 2. 2 times 2 is 4. And that's the answer. That's the equation of a circle. Now notice that the signs are kind of opposite. This is negative 2 for the x value of the center, so therefore it changes to positive. And this is positive 2 for the y value of the center, and therefore it changes to negative. So they're opposite signs. That's a good thing to note. So let's try number 44. So I'm going to go ahead and write that equation again, just so we know what tool we're using. And we want to find the center. So we count out 1, 2, 3, and then 1, 2. So 3, 2 is the center. I'll just write that up here. So we're going to plug in 3 for the x value of the center. And we're going to plug in 2 for the y value of the center. And you can see that the radius is just going to be 1. If you count from the center to the side of the circle. So 1 squared is just 1. And there's really nothing to simplify on the left side of the equation, so we just rewrite that. And that is the equation of a circle. So let's try a couple more of these. Again, we have a circle, and we are going to write the equation of the circle. Now we have to find the center, and it's going to be 1, 2, 3, 4, 1, 2, 3. So it looks like it's going to be 4, negative 3. So 4, negative 3. We're going to plug in those values. X minus 4, y minus negative 3, and then the radius is 1, 2, 3, so 3 squared, and of course we can just simplify. And we're done. So very easy, very simple stuff. Let's try one more of these before you try one on your own. Now, in this case, we can see the center is actually just 0, 0. And you know, before I was doing on the first problem, I was doing these endpoints. I guess you don't really need to. If you can see the center, it's pretty obvious. Center is going to be 0, 0. I'll just write that here. So that means it's just going to be x minus 0 squared plus y minus 0 squared equals, and then we just have to find the radius. So 1, 2, 3, 4. The radius is 4. And then we just have to simplify. Now x minus 0 is just x, and y minus 0 is just y, and 4 squared is 16. So when you have a circle with a center at the origin, you can see that the equation looks a lot more simple. All right, so I'm going to leave those problems in the window, and I want you to go ahead and try number 47. And when you come back, we'll do it together. All right, we're back. So it's a little harder to find the center on this one. I think it's going to be this point here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's pretty obvious that that point's got to be the center, and that is -1, -1. So let's go ahead and write the general equation. And we have -1 for the x value of the center, and also -1 for the y value. And the radius is going to be 1, 2, 3, 4, 5. So 5 squared. And of course we just simplify those double negatives. And we square the 5 and you get 25. So if you got that answer, good job. Again, notice that if you have -1 and -1, two negatives, they become positives in this equation. On the other hand, if you have positives, like 4, it becomes a negative. So that's a good thing to note. All right, try number 48, and when you come back, we'll do it together. All right, we're back. The center is 1, 2, 3, 4, so -4, 0. So x minus -4 and y minus 0. And we can see that the radius is just going to be 1. Again, the radius is the distance from the center to a side of the circle, so that's just 1 unit. And so we have the double negative becomes a positive, and y minus 0 is just y, and 1 squared is 1. So we can kind of just move this stuff together. And if you got that answer, good job. All right, try number 49, and when you come back, we'll do it together. All right, we're back. So it looks like this is going to be the center. And that point is 1, 2, 3, 1, 2, 3. So 3, 3. Looks like that's the center. I know it's tedious to have to continually rewrite that equation, but it'll help you remember it. And most importantly, you're showing the reader of your work what you're using, what tool you're using. 1, 2, 3, 4. Looks like the radius is 4. So we just square that radius, and that gives us our equation. So if you got that answer, good job. All right, try number 50, and when you come back, we'll do it together. All right, we're back. So we have 1, 2, 3, 4, 1, 2, 3. So -4, 3. negative 4, 3 is the center. So we have a double negative. And the radius we can see is 1, 2, so that would be 2 squared. Simplify the double negative. Oops, forgot to put a square there. And that should be your answer. So if you got that answer, good job. Now we're going to go backwards. Now we're going to start with the graph, or excuse me, we're going to start with the equation of the graph. And then we're going to write the circle. Now, it'd be nice if you had first of all, you should have graphing paper. You can't do this without graphing paper. And also, if you can use your compass, if you can get out your compass, that would be useful. I'm not really going to require you to use your compass, but now remember I mentioned twice that whatever these signs are, they change when you write the center. So we have -1, -1. You change it to +1, +1. So that would be here. And remember that this is equal to the radius squared. So the radius is not the radius is not 4. Okay, we know that r squared is equal to 4. So that means if you square root both sides, the radius is equal to 2. So what we do is we go out 2, 1, 2, and that gives us a point on the circle. And we can go out 1, 2 in the other direction. Whoops, that was too far. Go out 1, 2 and to the right, go out 1, 2 to the left. And you can see we have a circle. And just try your best. It's got to look like a circle. It doesn't have to be perfect, but it has to look like a circle. Mine doesn't really look like a circle much. I guess I'm not a very good drawer, but really you should be using your compass. But you know, that's the best we can do right now. The important point is that you know how to graph it. So let's try another one here. Now notice there's nothing here for this x squared. That means the x value of the center is 0. And the y value is 2, so 0, 2 would be here. Again, it's not -2, it's +2. You have to change the sign. And r squared is 9, so you square root that and get the radius. What number times itself is equal to 9? Well, that's 3. So you count out 3, 1, 2, 3, and mark that point. 1, 2, 3, mark this point. And I should probably be using red. 1, 2, 3, mark that point. 1, 2, 3, mark that point, and just connect the dots. I'm going to try to do a better circle this time. Yeah, that's a lot better there. It was better, but you get the point. All right, let's try number 53. Now we have a center that's -3 and -2. So -3, -2. That's our center. And the radius r squared is 1, which means r must be 1. So we just go 1 in all 4 directions, and then try your best to make your circle. And there you go. That was probably the best one I've done so far. It's probably best to write some points, especially the center point, but I'm not going to make you do that. We don't have a lot of time right now. All right, so let's try one more before you do one on your own. So the center is 4, -2. Now do you see I changed the signs? You have to change the signs. So it's 4, +4, -2, 1, 2, 3, 4, 1, 2. So that's the center, and just square root this number, and that's 2. And go out 2 on all the sides, and try your best to make a circle. My circles haven't been too good, but really it's just as long as you get the concept, that's fine. So you see how these circles are really weird looking. That's why you want to use a compass with your pencil. Remember, the compass is that thing that we used. And you stick the compass, you have your pencil here, you stick the compass at the center and just rotate it. Actually, I'll just keep that there. Okay, so now it's time for you to try. Go ahead and try number 55. And when you come back, we'll do it together. All right, we're back. So the center is not positive 1, positive 1. The center is negative 1, negative 1. So that would be here. Then we square root 16, and that gives us 4, and then count out 4. So 1, 2, 3, 4. And 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And just do your best to try to create a circle. And there you go. So if you got something like that, good job. Try number 56, and when you come back, we'll do it together. All right, we're back. So 1, negative 3. That'll be here. And square root 4, and you get 2. So the radius is 2. And connect the dots. And there you go. So if you got something like that, good job. Try number 57, and when you come back, we'll do it together. All right, we're back. The center is 0, 0, because there's nothing in those. There's no parentheses, because it was just x minus 0 and y minus 0. So the radius is the square root of 9, which is 3. So go out 3 in all 4 directions. And connect the dots. So if you got something like that, good job. Try number 58, and when you come back, we'll do it together. All right, we're back. The center is 5, 0. So that's here. And then the radius is 1, just square root of 1. Whoops. And connect the dots. If I were going a little slower, I could probably make these circles a little bit better. But we're kind of running out of time for this class. Okay, so if you got that answer, good job. Now we're going to try a few more problems here. Write the equations of the circles with the given characteristics. So the circle has a center of negative 3, 5, and there's a point on the circle, 1, 8. So if you draw a graph of this, you have negative 3, 5, which is about here, and then you have another point on the circle, which is up here. And we need to find the equation of this circle. So what we're going to do is write the general form of the equation of a circle, and we're going to plug in the point. The point is what goes into x and y. So we're going to plug in 1 for x, then minus the x value of the center, which is negative 3, and then we're going to plug in 8 for y, minus the y value of the center, and r we don't know. So all we need really to find is r, because we already have the center. We already have h and k. So then so I just want to color code this just so you see what's going on here. So that's where that stuff came from. So now we have 1 plus 3 squared, and 8 minus 5 is 3. I didn't really need parentheses on that 3, but 1 plus 3 is 4 squared. Then you get 16 plus 9, which is 25. And now at this point, you're going to be tempted to find r. It's important to understand that we don't need r. We just need r squared. In most cases, you need r in the previous problems that we've done today. But for this equation, for the general form of the equation, we only need r squared. So now we just write the equation. We go ahead and plug in the center. So I'm not going to do the double negative for you because that would be kind of repetitive. So we already have the center, and we just plug in r squared, which is 25. And that's it. That gives us the equation of the circle. So that's just kind of a specialty problem. This 25 here came from there. And hopefully you understand where the center came from. All right, so let's try number 60. We have center 1, 7. So we're going to plug in the 1. Now we're going to plug in, for x, we're going to plug in -2. And h is going to be 1. I don't need parentheses there. Y is going to be 5, and the center is going to be 7. And we can just find r. So -2 minus 1 is -3. And you definitely need parentheses for that because of the negative. 5 minus 2 is, or 5 minus 7 is -2. And we get 9 plus 4 is r squared, and 9 plus 4 is 13. So now we have r squared, and we can write the equation of the circle now that we have r. You have to have r in order to write the equation of a circle. Excuse me, you have to have r squared, not r. And there you go. All right. On to the next problems here. Actually, why don't you try the next problems? Next, number 61, and when you come back, we'll do it together. All right, we're back. As usual, I'm going to write the general form of an equation of a circle. And we have a point, so plug in 1 for x, and then -2, because 2 is the x value of the center, and then 1 for y, and then minus -5, because -5 is the y value of the center. 1 minus 2 is -1, and you definitely need those parentheses. Don't be writing this. That is not correct, because that is -1. This is not going to end up being -1. This is it's going to end up being +1. Then we have 1 plus 5 squared equals r squared. 1 plus 6 squared is r squared. 1 plus 36 is r squared. So we get 37 is equal to r squared, and now we can write the equation of our circle. And again, be aware, I know I've said this 3 times already, but you see the circle, we have +2, it becomes -2. We have -5, it becomes +5. A lot of students are really confused by that, but that's just the way that the equation works. We can give a more detailed explanation in further courses when we just learn transformations and so on and so forth. But for now, you just need to know how to do the equation. So number 62, well, first of all, if you got this answer, good job. Try number 62, and when you come back, we'll do it together. All right, we're back. Let's write that general form. So x, -7. Plug in the x value of the center. -2 for y. The y value of the center. -7, that becomes -7 plus 5. And I'm just showing every step here. -2 minus 6 is -8. And -7 plus 5 is -2. -8 squared is +64. And -2 squared is 4. Add those up and you get 68. So we have r squared is equal to 68. So now you can write the general form. Our center was -5 and 6. So if you got something like that, good job. All right, we just have 4 more problems for the day here. It says here, find the same problems, write the equations of the circles with a given characteristic. So now the characteristics is we have a diameter with endpoints 4, 2, and 8, 6. So what that means is if you graph this, we have 4, 2, and we have 8, 6, which is here. So that's a diameter. And what that means is that the center has got to be here. And you draw your circle like so. I didn't draw it very well, but you get the point. So what we have to do is find the center. Now notice that the center is the midpoint between those two endpoints. So we have to find our midpoint formula. So the midpoint is something we learned in a previous class. If you don't remember the midpoint, that's okay. I'm going to write it right here. So that's the midpoint of these 2 points here. That's going to be the center of the circle. So we have 4 plus 8. Those are the x values of the points. And then we have 2 plus 6. Those are the y values of the points. And we divide by 2. 4 plus 8 is 12. And divided by 2. And 2 plus 6 is 8. Divided by 2. And then we get 6 and 4. That's the center. All right, so now we can easily write the equation. Now, we need to know the radius. There's a lot of different ways you can find the radius, but I'm just going to find it. I'm just going to go from, we have a center, and we also have points on the circle. So really, it just becomes the problems that we just did. So that's the way I'm going to solve this problem. So I'm going to take 4, 2, and that's a point on the circle, and then we just start from where we left off on the other problem. So x minus h squared, y minus k squared equals r squared, and we just plug in numbers. So x value is 4 minus the x value of the center squared. Y value of a point is 2. Y value of the center is 4. And we just use that information to find r squared. So we get -2 squared plus -2 squared equals r squared. And 4 plus 4 is r squared. Sorry, that writing is kind of sloppy there. 4 plus 4, so 8 is r squared. And now we have the center. So we plug in those values for the center, and we have r squared is 8. So that problem is a little more complicated, but really it's not that difficult. A lot of students will say, well, that's too complicated. Well, no, it's not. It's just a standard math problem, and instead of complaining, you just need to figure it out. Just figure out the problem and do it. All right, number 63, let's try this again. Another problem like that. So we need to use the midpoint formula, and I probably don't need to keep rewriting these formulas for time's sake, but I really want you to understand what's going on. So I'm going to rewrite that. So 5 plus 3 over 2. The midpoint is the center of the circle. So we get 8 over 2, and -7 plus -4 is -11. So now we have a fraction. 8 over 2 is 4, and we have -11 over 2. And you can change it to a decimal if you want, or you can just keep it as a fraction. I'm just going to keep it as a fraction. So now we can choose one of these points. We don't need both of them. I'm just going to choose the first one, 5, -7. So now it reduces to the problems we did before. So now I'm going to write that general form of equation of a circle, and we just plug in like we did in problems 59 through 62. So let's see here, plug in the x value of the point and the x value of the center, and the y value of the point and the y value of the center. I need to focus in here. And we're using that information to find r squared. Just make sure I got that right. Looks right. So 5 minus 4 is 1. And actually, now I think of it, it's probably going to be better to change that to a decimal. So let's change that to negative 5.5. So negative 5.5. So that becomes negative 7 plus 5.5. So 1 squared is 1, and negative 7 plus 5.5 is negative 1.5. You can use a calculator for this stuff, it's okay. And negative 1.5 squared is positive 2.25. Add those together and you get 3.25 is r squared. So now we're ready to write our final equation, x minus 4 squared plus y plus 11 over 2 squared equals r squared, which we just found is 3.25. And that is the equation of the circle. All right, I'm going to leave those in the window. Try number 65, and when you come back, we'll do it together. All right, we're back. I'm going to copy this formula for the midpoint, throw that on there. And I'll go ahead and do it for the other problem also. I just want you to be absolutely clear what the tools that we're using. So add the x values and divide by 2. Add the y values and divide by 2. And we get 10 over 2 and 0 over 2, which becomes 5, 0. Any fraction with 0 in the numerator is going to be 0. So that is the center, and then we can use any one of those points. I'm going to use 4, 1 because that doesn't have any negatives. So now we're going to write the general form of a circle, and x would be 4 minus the x value of the center, y would be 1 minus the y value of the center. And you can see this math is going to be pretty easy. So we have negative 1 squared plus 1 squared is equal to r squared. And we got 1 plus 1 is r squared, and r squared is going to be 2. So now we can write the final form, x minus the center, the x value of the center, plus y minus the y value of the center, and r squared is 2, and we're just going to simplify that a little bit more. So x minus 5 squared plus y squared equals 2. And so if you got that, good job. As you can see, these problems, they may look a little complicated, but they're really not. They're really pretty simple. So try number 66, and when you come back, we'll do it together. All right, we're back. So let's find the center of the circle first. Negative 7 plus negative 2 over 2. And negative 3 plus negative 4 over 2. And we get negative 9 over 2. and -7/2. And I'm just going to change those to decimals. You can use your calculator for that if you need to. So that is the center. And I'm going to choose just the first point up there, -7, -3. That is a point. You can choose either one of those points up there. It doesn't matter which one. Just choose whatever seems easier. Alright, so now we're going to write the general form of this equation of a circle, just so again you see the tool that we're using. And we're going to plug in the numbers to find r squared. So minus -4.5 and y minus -3.5. So I know this seems a little complicated with all this stuff, but this is really just basic arithmetic. And you can use your calculator if you need to, but these calculations are fairly easy, so that shouldn't be necessary. Double negatives become positive. And -7 plus 4.5 is -2.5. And -3 plus 3.5 is 0.5. So -2.5 squared, again, you can use your calculator for that. That calculation is not that easy. 6.25. And 0.5 squared is 0.25. Don't be afraid to use your calculator on those problems. Add those up and we get 6.5 is equal to r squared. And so now we can look up to the center there. We have, I'm going to use the fractions. Remember, you have to change the signs. And x plus 7/2 squared equals 6.5, and that is the equation that we're looking for. So if you got that answer, good job. That was kind of a doozy. So that was the class today. Let's go back and take screenshots of all the work if you want to use this for these notes for your homework or to study for tests. This is screenshot number 1. Screenshot number 2. Screenshot number 3. And number 4. And number 5. And number 6. And number 7. And number 8. And number 9. And number 10. And number 11. And number 12. And don't go before you get the homework. Remember, the homework is the most important part of this course or any math course. So get screenshot number 1 and screenshot number 2. Screenshot number 3. Screenshot number 4. Screenshot number 5. And screenshot number 6. Remember, if you don't do the homework completely and correctly and neatly and put it in your binder, you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.